back. Today we're talking about graphing linear inequalities. Let's get started with some things we need to know. So remember, equations have only one solution and inequalities have many solutions. Now let's take a look at an inequality and see if things are solutions. So before we begin, we're going to determine if these things are solutions. So we've got 2 points there, 0, 0 and 0, 1. So we're going to determine if these are solutions to our inequality by substituting them in for x and y. So we've got 2x minus 3y is greater than or equal to negative 2. So we're going to start with the 0, 0. So we're going to substitute that in. Remember, when we substitute in, we're always going to use parentheses. So we're going to plug in the zeros, and then we're going to have greater than or equal to negative 2. So now we're going to do some quick math, and 2 times 0 is 0, 3 times 0 is 0, and we end up with 0 minus 0 equals 0. So we've got 0 is greater than or equal to negative 2. So we need to determine, is this a solution to this inequality? Is 0 greater than or equal to negative 2? No, it's not, so this is not a solution to our inequality. Now let's try the other side where we've got 0, 1. So again, we've got 0 for x, but this time we've got 1 for y. So we're going to plug in everything that we have. So 2 is going to get a 0 next to it again. But this time we're going to plug in 1 for y. It's greater than or equal to negative 2. We're going to do some math. 2 times 0 is 0. 3 times 1 is 1. And we end up with 0 minus 3, which is going to be negative 3. And we get negative 3 greater than or equal to negative 2. So again, we need to determine, is negative 3 greater than or equal to negative 2? And it's not, because it is not greater than negative 2. Remember, when we have negatives, negatives are going to be the smaller the negative number, the greater the value. So in this case, again, this is not a solution. We would need the number to be greater than in order for it to be greater than or equal to negative 2 for it to be a solution. Now let's take a look at some more information. Now, when we go to graph a linear inequality, we have a few steps to remember. The inequality must be in slope-intercept form, so y equals mx plus b. Remember, we're going to have that as our guiding principle here. If the sign is less than or equal to or greater than or equal to, we're going to use a solid line on the graph. If the sign is less than or greater than, we'll use a dashed line. And we're going to shade the coordinate plane with the solutions to the inequality. And we have to test a point to determine where we shade. So now let's take a look at this with example A. So here we are at example A, and it says graph the inequality. So we have to do a few things first. One, we need to make sure that it's in slope-intercept form, which is y equals mx plus b, or in this case, we're going to have an inequality, so we're going to have y is less than mx plus b. So we have to check. Now, we have the y by itself, and it's not on the side that we normally see it on, but it is relatively close to what we see. So I'm going to reorder our inequality so it does look like slope-intercept form. We have to make sure that we keep the sign the same. So I have y less than 2x plus 1. Okay, that was what it was above, and I need to make sure that it's the same, that my less than symbol is still pointing towards the y like it was above, and it is now below. So now that I've done that, it's time to graph. So I'm going to put my graph here, and I've got a positive 1, so I know my y-intercept is 1, and I've got a slope of 2. So that means I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and I can go the same thing the other direction, down 2 over 1, down 2 over 1, down 2 over 1. Now it's time to make a line. So since I have just less than, not equal to, that means my line is going to be dashed. So I'm going to put a dashed line through my points here because I don't know if it's less than, or I know that it can't be exactly this inequality. So I've got my dashed line there. Now I need to determine which way I need to shade. In order to figure that out, I need to substitute in a point. I can pick any point on the graph, but the easiest point to pick is obviously the origin of 0, 0. So I'm going to plug in 0, 0. If it turns in to be a solution, then I know that that's the side I need to shade. If it turns to not be a solution, then I'll shade the opposite side. So let's take a look at that now. So I'm going to plug in 0 for y and 0 for x and determine what we've got. So 2 times 0 is 0, and positive 1 plus 0 is going to be 1. So I've got 1 is greater than 0. So let's see, is that true? 1 is greater than 0? Yeah, that is true. So that means I'm going to shade that side where that point exists. So that point exists is over here, and it is part of the solution. So I'm going to shade everything to the side of the graph where that is a solution. Now let's take a look at example B. So here we are in example B, and again we have to graph the inequality, but of course we want it to be y equals mx plus b, or in this case we're looking for y is greater than or equal to mx plus b. So the bad news is that my inequality is not currently in slope-intercept form. So I have to make it in slope-intercept form by moving that 2x to the other side. So I'm going to do that by subtracting 2x on both sides. These are going to cancel, leave me with just y, keeping my sign the same because I did not multiply or divide by a negative. I did subtraction, and I've got negative 2x plus 3. So the good news is now my line is in slope-intercept form, and I can graph it. So I'm going to graph positive 3 as my y-intercept, and I've got negative 2 as the slope. That means I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and I can go the same thing the opposite direction, up 2 over 1, up 2 over 1. All right, so now I need to pick a line, and I can see that it is greater than or equal to, so in this case, I'm going to have a solid line. So I'm going to have a solid line going through my points, and again, this will be a lot easier for you because you'll have a line tool. I'm going to try and do my best here, and I've got arrows on the end because remember, these are not the only solutions. So now I need to determine which way am I going to shade. So I'm going to pick a point. Again, you can pick any point on the graph that you want, but I'm going to pick 0, 0 because that's the easiest one for me to use. So here we go. We're going to plug in 0. And plug in 0 for our x, and now we're going to do some math. So negative 2 times 0 is 0, and we end up with 0 plus 3 is 3. So we've got 0 is greater than or equal to positive 3. So now we need to determine, is that statement true? Is 0 greater than or equal to 3? No, it's not. So that is not a true statement. So that is not a solution. So we're going to graph the opposite side of the graph because that is not a solution to the graph there, or a solution to our inequality. So we're going to make sure that we graph the away from that point. Now let's take a look at the next example. So here we are at example C, and this time they've given us the graph, but we need to write the inequality. Now the bad news is this is not going to be in slope-intercept form because I can see that we have a vertical line here, which means we've got an undefined slope, and we know when we see those types of graphs, we're going to have x equals 2, or x is greater than, or x is less than, or greater than or equal to, or less than or equal to. So I know I'm going to have some sort of thing with my x, so that's going to be what I'm going to write first. Now I've got to determine, do I have a vertical line, which I do, and I have to determine, is that going to be a solid line or a dashed line? Since it's solid, I know I'm going to have either greater than and equal to or less than or equal to. So now I need to determine which one that's going to be. Well, I can see that all the points here are at negative 3. All of the x values are at negative 3, so I know that I've got negative 3 in my inequality, and now I just need to determine where my sign's going to go. So the good news is that I've got a shaded area where all of the numbers to the right of negative 3 are being shaded. So all the numbers greater than negative 3 are the ones that are falling in the shaded area, right? Positive 1, positive 5, positive 10. All those numbers are greater than negative 3, and that's the area that's being shaded. If all the areas on the other side are being shaded, that's the sign that we would choose, but we're looking for all the numbers that are greater than or equal to x, and again, we're using the greater than or equal to sign because the line is solid, so that is our inequality. Now let's move to the next example. Here we are at example D, and again, we've got to write our inequality based on our graph. So we have to, again, look for y equals mx plus b, because that's the form that we're trying to do. But again, we've got an inequality, so it's going to be less than or greater than or equal to or less than equal to. So I know I'm going to have y to start, and then I've got to determine my intercept and my slope. So those are the easy things for me to do, hopefully, at this point. So I can see that the line is crossing at positive 2, so I know that my equation is going to have plus 2 on it, or my inequality is going to have plus 2. And then to determine my slope, I'm going to just count up and over 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1. So I can see that my slope is going to be 2. There for including my input. So now I just need to determine my sign. So I can do this a bunch of different ways, but I can tell that we have a dashed line, so I'm either going to have less than or greater than. Now I have to determine which one it's going to be. So the only way to do that is to substitute in a point of my choosing. Again, you can pick any point on the graph, but I'm going to pick 0, 0 because that's my easiest one to do. So I'm going to take what I do have, which is 2x plus 1, and substitute in a 0 there. So if I do 2 times 0 is 0, 0 plus 2 is going to give me 2. So I end up with 2 is going to be looking for something with 0. So now I have to make sure that this is true. Since that is the point that's fallen into the shaded region, I want this to be a true statement. So in order to make that true, 0 has to be less than 2. And since I have less than 2 there, I have to put less than 2 into my equation. Now let's take a look at the last example. All right, here we are at example E, and again, we have to write our inequality based on the graph. So again, I'm looking for y equals mx plus b. All right, so the easy things for me to do, I know that it's going to be y. I can see that it's a dashed line, so that tells me it's either going to be less than or greater than, no line underneath. Now I need to determine my y-intercept, and I've got to determine my slope. So where the line crosses is at positive 1, so I know that's going to be on the back. And then I know that I'm going down 2 over 1, down 2 over 1, down 2 over 1. So I can see that my slope is going to be a negative 2 here, and I can see that because my line is going down. So now I need to determine, is this which way am I going to shade? And I've got to pick a point on the graph. Now, so far I've been picking 0, 0, and I'm going to change it up now just so that I have a different point so that we can see that any point on the graph is really one that we can choose. So I'm going to choose +1, +1. Almost as easy as 0, 0, but that's the point I'm going to pick. So I'm going to plug in 1 for y, and then on the other side I'm going to have -2, +1, +1. So -2 times 1 is going to be -2. -2 plus 1 is going to be -1. And I've got -1 and now 1. So I can see that this point is not inside the shaded region. And since it's not inside the shaded region, I want to make this a false statement because I want to make sure that the solutions are shaded. So in order to make this a false statement, I have to make it a less than symbol because 1 less than -1 is a false statement. So that area will not be shaded. So therefore my less than symbol is what I'm going to use in my inequality. That brings us to the end of this problem. It also brings us to the end of this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.